And now it's time for our very first chapter of this year's global trends called Supernature, or how to observe and explore nature in a respectful way to then be able to harness its powers.
Hello again. It is time now for the first chapter, as Julia said, of this year's Global Trends Award-Winning Innovations. As we just saw there, the chapter is entitled Supernature. Now, Sylvain was saying a little earlier on, we're going to be talking quite a lot about mushrooms today, just to give you a little taster of what's coming up ahead. We're also going to be talking a lot about the construction industry, which we all know is hugely polluting. Well, I'm here with Marcus Goddard, who is the VP Intelligence of 2050 now La Maison. Welcome to you, Marcus.
Tom.
Marcus, just tell me why it is, in your opinion, that mushrooms or fungi have become such a key focus this year.
Well, fungi is really something that's taken us by surprise in the past year or two. It's a whole sector, a whole industry with thousands of startups that have been growing quietly in the dark and then have emerged out into the light in the past year or two, just like real mushrooms, real fungi. There are innovators all around the world who are working on ways to use mushrooms to store carbon, to create alternatives to plastic, alternatives to meat, to use them for health, for mental welfare, which people have been doing for centuries, obviously. So this is a really fascinating sector that's starting to structure. There's a whole industry that's emerging, and projects are starting to scale up in several countries in Europe in particular. So at La Maison, we're keeping a very close eye on the fungi industry. This is a thing I wouldn't have thought 2 or 3 years ago. I would have said that. The fungi startup sector is absolutely fascinating, and we're going to see a little bit about it in the next few sequences.
Absolutely. Well, our first award winner turns toxic waste from the construction industry into green materials, and it does this, as we've been saying, with the help of fungi. They've trained mushrooms or fungi to break down construction waste. They can then use that waste as a biomaterial, which can be used in packaging, insulation, or as a clean building material. Well, I spoke to this innovator. It's called MYCOCYCLE. The founder is Joanne Rodriguez, and I spoke to her and asked her how she came up with this idea in the first place.
I came up with this idea after spending decades in the construction products and material manufacturing sector as a director of sustainability. The majority of the products that we manufactured came from petroleum and contained a lot of plastics. I left the corporate environment after having no solutions for these waste streams, and discovered that fungi had the innate ability to reduce heavy hydrocarbons in nature. And those are the same types of toxins that were contained in the materials that we produce as an industry. And I decided to apply that very remedial to a handful of shingles that would go like on your house, and had some success. And it was from there that MYCOCYCLE was born, as an idea to try to divert this 4th largest waste stream that hits landfills every year worldwide.
MYCOCYCLE could have a huge impact on the construction industry and in turn on pollution levels.
Correct. So we are essentially decarbonizing the construction materials supply chain. 11% of all of the world's greenhouse gas emissions come from materials within the construction industry. And so we're building cities the size of New York and Paris every month for the next 40 years because we have a global rise in population, which means more materials. We need to figure out a way to create a greener path forward. And that's where the idea of transforming waste to value using partnering with nature really is key and critical to us. We train mushrooms to eat trash to create these renewable bio-based raw materials because we could start to really chip away at the greenhouse gases and create new forms of biopolymer plastics that can go back in a circular manner to the products that are used in the construction industry.
To ask you, how do you actually go about training a mushroom?
Well, mushrooms are very much like humans, and when we start, we're exposed to different things as children, and we adapt and develop a tolerance and some resilience to this. It's very much the same where we're able to take a species of fungi and expose it and work through principles of adaptive evolution to make them stronger with the capacity to handle waste head on. And so when we're operating in the field, we're very aware that we are not in sterile conditions. We're dealing with trash. And so we work to create a very high quality enzyme that's very robust and resilient. The ability for it then to grow through waste materials like rubber or carpet within a matter of a couple of weeks to detoxify them is nothing short of extraordinary. And then we hold the capacity to continue to help the species evolve and take the best in class and create the super treatment that will allow us then to have the best material path forward.
Sounds incredible. I just wanted to ask you, where are you now in terms of rolling out MYCOCYCLE to the construction industry, and what sort of a reception are you getting from people in that industry?
If you could imagine that we're dealing on both sides in our circular economy with very difficult industries. With the waste sector, they haven't changed their practices of burning and burying waste for decades until legislation says that they have to. And then on the construction industry, there's a need to create a very durable component, right, and warrant these materials. And so there's some skepticism to take on new innovations, take on new ingredients, or reformulate their products due to liability. I think my background in this industry, though, has been very helpful. When I say I'm the CEO, I really think about it as the Chief Education Officer. There's a lot of conversations around the innate ability of nature to be optimized and to create a solution set that is viable. So where we are in our development is commercial stage. We are actively negotiating commercial contracts, not only on the treatment of waste, but on the offtake of the new materials. Some of these are with global manufacturers, some of whom are headquartered over in the European markets. And we believe within the next 12 months, we will have product into the field in every type of material possible, flooring, walls, ceiling, and building insulation.
And so now that you're focused on bringing this innovation in the construction industry, I was wondering what other applications you were considering for this innovation.
So one of the big applications is around end-of-life tires. So rubber that you would see in infill projects that go into artificial turf, so your soccer pitches and athletic fields worldwide. In the EU, there's already a ban around the use of these polymers, this rubber crumb, because it's considered to be a microplastic. We are very close to cracking the code on turning around a new form of biopolymer plastic that would de-risk these materials and allow us to recycle rubber in a completely different way. This would be a huge advancement for us, as well as globally for the use of these materials.
So, like as you said, if your fungi can break down this many different types of materials, I was wondering if you were concerned by any potential risks to the fungi spreading beyond a controlled environment and potentially breaking down other things that we wouldn't want them to break down.
For sure. So the unintended consequences, will this be like The Last of Us, right? The reality is that we put in really controlled systems to make sure that we don't have what would be called a spore release. We don't get to a fruiting body. So if you think about the mushrooms that you put on your pizza or that you have in your risotto, we don't get to that point. That fruiting body is what could actually result in a spore release and could potentially create an issue. We just don't grow that far.
Okay, thanks for that. And I just want to ask you lastly where you are with regards to scaling up this innovation and what sort of challenges you've been facing along the way.
The overarching challenge that we face is rolling out the first of a kind technology with so many variabilities. We have treated a multitude of materials across the construction and demolition sector, everything from flooring to roofing. And so developing a pathway that allows us at scale to get offtake agreements in place, to find the reuse path. It really is not our ethos to just treat and detoxify the materials today. We really are challenged to create these higher value reuse paths. So the challenge has been and will continue to be to build up both sides of this marketplace so it is a viable solution. We are seeing success in this, and as we roll this out, there'll be less skepticism about the ability for us to scale and treat waste.
All right, well, thank you very much indeed for taking the time to speak to us. Joanne Rodriguez, the founder and CEO of MYCOCYCLE, thank you very much indeed.
Tom, thank you. I really appreciated the opportunity to speak to the Global Trends Forum in 2050 now. I feel bad that I can't be in Paris in April. I couldn't imagine a better place to be. And I want to leave you with one thought and ideology that we approach every day, which is there's no waste in nature. Nature is a man-made construct, and we're solving this problem one mushroom at a time. We're encouraged in the worldwide approach of using fungi to solve some of these heavy industrial solutions. So thank you again for the recognition and the opportunity to speak to the group today.
Well, thank you very much indeed.
Okay, so that was Joanne Rodriguez speaking to us there about MYCOCYCLE. Who knew you could train a mushroom? I certainly didn't. Let's talk, Marcus, about the theme of this segment. We've entitled it Supernature. Just tell us what we actually mean by that.
Supernature, I think Joanne gave us a lot of insight into that. She says there's no waste in nature, and Romain Troublé earlier was talking about the resilience of natural ecosystems. And the idea of supernature is that we've seen so many projects and so many innovators and bright ideas like MYCOCYCLE and MAESTRO with AI timber that we're about to see that talk about making nature part of the solution, using the superpowers, the unique qualities of living things and applying them to real world problems, how to make construction sites cleaner and how to make them more efficient, how to decarbonize whole industries. That's what we mean by supernature, using nature, living things almost as like a factory for solutions.
Okay, thanks, Marcus. So that was our first innovation of the day. Throughout the day, we'll be putting up on the screen here a QR code, just like this one, there you are, with all the innovations on it. And later on, we're going to be asking you to vote. So that was MYCOCYCLE, amazing mushrooms in that story. Let's move on to our next innovation. And as I mentioned, the construction industry is going to be a big focus today. Building materials, especially cement, are very far from being green. And that said, we're going to show you an example later in the day of how, in fact, cement can be green, can't it, Marcus?
Absolutely. We were talking about about cleaning up construction waste. We're just about to talk about new resources for buildings. And later on, we'll be looking at how the cement industry, which gives off huge amounts of carbon just through the chemical process used to make it. If you change that process, maybe there's a way of making even that more sustainable, because we're not going to stop building things. So we need MYCOCYCLE, we need the next innovation that you'll see to help us build things more rationally and more sustainably.
We do, because these things are really the exceptions rather than the rule. The carbon footprint of the construction sector, that includes building materials and processes, account for more than 10% of global emissions. But this next innovation we're going to look at now, MAESTRO Technologies, aims to make construction greener by using the power of software, and natural materials are also a really big part of it. And AI is helping to supercharge some of the efficiencies there as well. This startup was co-founded by the MIT professor Carlo Ratti and also by Mykola Murashko, who joins us now. Hello.
Hello,
Nice
thank you
to
for
have
having me,
with us.
guys.
Welcome, welcome. Your startup is called MAESTRO. The product is called AI Timber. Tell us in your own words, what this is all about.
Yeah, sure. So MAESTRO at its core is a software technology company. What we do is move the complexity of construction, complexity of the building process, from the construction site, which is usually the origin of a lot of inefficiencies, to the CNC machine. The machine that, with just a few lines of code, can create components that are precise, that are bespoke, and most importantly, that we can control using software. So what we do is we take architecture as an input and translate that architecture into a set of components, and then generate code to produce those components. That means steel components, that means timber components that are machined in a precise way and delivered on site for assembly. Now, this means of building has huge efficiencies in terms of speed and cost and time, but we really founded MAESTRO to tackle the carbon question, the carbon challenge in construction. And the way to do that is not only to create efficiencies inside of the production process, but to look upstream, to look at what kind of building materials we use in order to build. And here, natural materials have a huge role to play in that. So we're just completing our first building in the US, where we are using CLT, that's cross-laminated timber. Cross-laminated timber is a manufactured timber product which takes planks of wood and laminates them in a cross-laminated fashion in order to create building products that are engineered, so that means they're predictable in terms of mechanical properties, but they're also rather large scale. So with CLT, you can build things that are up to 6 stories high. But the real advantage there is that building with CLT, building with wood, means that your building turns into a carbon store. Now, your building captures that carbon that the tree sequestered during its lifetime and locks it inside for 100 years. And this is very exciting, and the potential of carbon sequestration using mass timber products is immense. And we are very excited about pushing the boundaries of what's possible when it comes to that. And the way we do it is by tackling a very simple problem, which is when CLT is produced today, you take regular-sized planks and you laminate them. But to get to a regular-sized plank, you have to start with a tree that has natural forms, organic forms, that must be sawmilled. This sawmilling process is actually the crux of what we're trying to tackle with AI Timber, which is a new production process patent. What we're doing is, instead of sawmilling regular planks, we have come up with a process whereby you can LiDAR scan the log, the raw material, and then using a bit of machine learning and a bit of AI, you can define what is the most efficient possible manner in which you can sawmill the log and then keep the organic geometry of the boards in order to then laminate them into a panel which preserves the natural forms of timber, preserving the natural shape of the forest, and in doing so, creates panels that are much more materially efficient than would otherwise be possible. So we're looking at about a 30% improvement in terms of material efficiency, and that means 30% more carbon locked inside of our buildings for generations to come.
Okay, let me just stop you there. You've raised lots of important points. What you're basically saying is that software is powering construction in the case of AI Timber and what you're doing. Is that it?
Yeah. So, and to be clear, we do it in 2 different ways. So the core product that MAESTRO sells is a software that can interpret architecture and bridge between architecture and digital production, right? That enables us to build with these custom but yet precise components and build faster. But in order to push the limits of what's possible using software, especially when it comes to decarbonizing the industry, we have gone upstream. We have gone to the level of the material. And that's where we can make exciting steps forward, like AI timber, for decarbonizing the very material that we build with.
Okay, so obviously natural materials absolutely at the core of what you're doing.
Yeah. I think the overarching theme here is that in this moment whereby construction is facing a crisis of being behind, of being full of inertia. Construction is the second lowest industry when it comes to R&D spend as a percentage of revenue, followed only by hunting as the last. So in this moment where construction is facing a big crisis, I think it's important for us to learn from nature, to learn from the intelligence of nature and apply that intelligence to our building processes, to our building materials, in a manner that can supercharge the building of tomorrow.
Yeah, might also make some of them look a bit nicer as well. Talk us through AI and the potential of natural materials really being supercharged in construction by AI.
Yeah, sure. So what it comes down to is when you're using building products, what you want is a standard rectilinear product that you can apply across different use cases. An architect will have their ideas that are project and site specific, and you want to provide materials that can form to those requirements. Now, in order to do that, those building products must be as generic as possible. But if we want to make building products, generic building products from nature, we must be able to interpret, to translate the organic forms of nature to the standard forms that are required for our day-to-day needs. And that's where machine learning and AI can really help us to interpret that complexity of nature and be able to translate it into products that can be used commercially day-to-day.
Okay, thanks for that, Mykola. Our Mars crew member, Erin, is here with me on the stage, and for all of the innovations, we'll be involving our Mars crew members who'd like to put some questions of their own forward. So she's got a question for you. What is it?
Yeah, thank you. I was wondering, do you think that similar technologies could be applied to other materials apart from wood, for example?
That's interesting. So for certain, we're applying AI across material categories in our product that we use in order to interpret architecture into components, right? So at that level, at the level of the design for manufacture, we're using AI to help us perform the design for manufacture process, and that applies to steel components, that applies to timber components, but it also applies to precast concrete components, making them more efficient. However, when it comes to using it upstream, using it at the level of the material, I think we have to be mindful that natural materials can be unpredictable, and so we need to be careful about how we use them in the construction industry, because in the end, if we're talking about structure, that is something whereby we have zero tolerance for risk. So the way that we use AI in the sector must come with a bit of caution.
Okay, well, thank you so much for taking the time to tell us all about that. I think we've got an award for you, which will be presented to you now. We'll also have a photograph here in the middle of the stage.
Wonderful.
So don't go running away just yet. And remember, as with all of the innovations, you will be able to vote. Let's bring the award on stage.
Thank you.
Okay, don't run away just yet. I just have another question for you, actually, Marcus, because we've been talking about construction using natural materials. I mean, do you think we're far away from the day that a skyscraper is made out of wood?
Well, I don't think we're very far at all, because obviously we did some research around the project, looking at some of the most exciting architectural projects around the world, many of them coming out of the Calderetti studio. And we saw that in Australia, there's a project that's already underway to make a 300-meter skyscraper largely out of wood. And so it seems to us like artificial intelligence is fulfilling its promise in unexpected ways. As Mykola said, it's translating an idea into concrete reality. In this case, it's translating architectural inspiration into real-life buildings using more natural resources. So I believe we'll be seeing far more cutting-edge, stylish buildings made out of wood in the next decade or so.
Are you anything to do with that skyscraper?
No, not yet.
Not yet. Okay, well, that's
so Maestro is about 9 months old, and so
Yeah.
far we're building fewer square meters than that. But soon, I promise.
Clearly, the sky is the limit. So thank you so much, Mykola, Murashko. Thank you so much for telling us about that.
Thank you.
Up next, we're going to be crossing back to Julia, who's on the stage just up here. She's going to be telling us about a startup that was incubated here at Station F. It's called Numi.